In this video, I want to talk about the law of cosines, which is a set of equations you can use to find the angles and side lengths of any triangle. So, given triangle ABC, like we have here at the bottom, the law of cosines is this. A squared equals b squared plus c squared minus 2bc cosine A. Then we can repeat this using side length little b. So b squared equals a squared plus c squared minus 2ac cosine b. And finally, we can do the same thing for little c. C squared equals a squared plus b squared minus 2ab cosine c. So you'll notice that there's a pattern across all of these. Depending on what side length we're looking for, the other side is going to use the remaining sides in the equation. So we have a, and then on the left, and then on the right we have b squared plus c squared minus 2bc something else. You'll also notice that the letter of the side we're looking for matches the angle and the cosine. So that's the same across all of these equations. Put my box there and here. Given the law of cosines, we can also derive the Pythagorean theorem by assuming that one of the angles is 90 degrees. So in this case, we're going to use the equation that uses c squared on the one side just because it matches Pythagorean theorem. And then we're going to set angle C equal to 90 degrees. So if we write this all out again, c squared equals a squared plus b squared minus 2ab cosine 90, we'll notice that this whole term is going to drop off because cosine 90 is equal to 0. So we can just erase all of this. And then what we're left with, if we clean this up a tiny bit, a squared plus b squared equals c squared. So there's your Pythagorean theorem. Alright, now let's look at some practice problems where you can use the law of cosines to figure out the missing angle or side that you need. The first type of practice problem is a side angle side problem where we're given two sides and the angle between them, right here. So in this example, we're going to start by using the law of cosines. Law of cosines. And we're going to find little c here. So let's write out the equation. C squared equals a squared plus b squared minus 2ab cosine of c. Then we'll plug in our values. 14.1 squared plus 8.9 squared minus 2 times 14.1 times 8.9 times the cosine of 67. Then if we do this, all the math out, this is going to equal c squared equals 179.24. Take the square root. C is equal to 13.38. Alright, so that was step one. We found the side. And in all these problems, you're going to follow the same set of steps. Basically, you're going to use the law of cosines first. And you're only going to use it one time. Then you're going to use the law of sines times 1 or 2 or 3. Basically, the law of sines is a little bit easier to manipulate or use. So you're going to find the missing angle or side first using law of cosines, and then you're just going to keep using law of sines until you figure out the rest. So for us, we're going to move on to step 2. And in that one, we're going to use the law of sines. And here we want to find the angle A. So we want to find this angle. So let's write out the law of sines. Sine of c over little c equals sine of A over little a. This becomes sine of 67 over 13.38, the side that we just found, equals sine of A over 14.1. Then if we do this and multiply across, we're going to get sine of A equals 0.97. Take the inverse of this, sine -1 of 0.97, and we're going to get A equals to 75.94 degrees. Okay, so we'll plug this in, 75.94 degrees, and then we'll actually plug in C as well, which is 13.38. Now, we're going to move on to step 3. And again, if we're looking at our little rule here, we're going to use the law of sines again. For this one, we're going to try to find angle B. So we're going to have sine of B over little b equals sine of C over little c. This one's pretty straightforward. Sine of B over 8.9 equals the sine of 67 over 13.38. Sine of B equals 0.612. And then we take the inverse sine of the arc sine of that, and we get B is equal to 37.76 degrees. So using the law of cosines and then the law of sines twice, we can figure out all of the angles and sides of our triangle. The second example where the law of cosines comes in handy is a side-side-side triangle, where we're given all the sides but none of the angles. So in this one, we're going to follow the same set of steps. First, we're going to start with the law of cosines. And here we're going to try to find angle A. So we're going to find this angle. So A squared equals B squared plus C squared minus 2BC cosine of A. And you'll notice that the angle's on this side of the equation, so we're going to have to do some rearranging to get that in the right spot. We'll plug in our values that we know. 16.7 squared plus 18.9 squared minus 2 times 16.7 times 18.9 times the cosine of A. Alright, so we're almost running out of space here. That's why we can move it. And then we do some math. We're going to have 631.26 cosine of A. So basically I solved this part and then brought it to the other side. That's going to equal 129.85. All right, then we're going to divide by 631.26. We're going to get cosine of A equals 0.206. And then we'll figure out that angle A equals 78.13 degrees. So put that in here, 78.13. Now, step 2, we used the law of cosines once, so we're basically done with it. Now we're going to move on to using the law of sines. And here we want to find angle B. So let's set up law of sines. Sine of A over A equals sine of B over B. Plug in our values. 3 over 22.5 equals sine of B over 16.7. Then we're going to get sine of B equals 0.726. And using the arc sine, we can find that angle B is 46.58 degrees. All right, now clean up some space over here. Step 3, we're once again going to use the law of sines. And in this case, we're going to look for angle B. No, angle C. All right, so here, set up our law of sines. Oops. Then we're going to have sine of C over 18.9 equals the sine of the angle we just found, 46.58 over 16.7. Sine of C equals 0.822. And then using arcsine, we can find angle C is equal to 55.29 degrees. And that's it. We've figured out everything that was missing here.